All right. Hello, my name is Liam, and this is the second component to my chess software video. So I'm just gonna show proof that this is actually working. So let's begin. All right. So to run this usually, I like starting in the terminal. So uh, since this is a Rust project, you can do cargo run. And that compiles an executable and runs it. Um, I can also show the build feature if you want me to uh, later. But anyways, let's get started. Um, so right now we have the chess board on the right portion of the screen and the terminal on the left portion of the screen. So Uh, currently, I have disabled the chess algorithm for the blue players, so it's just gonna be me controlling the moves to make this a bit faster. So for example, um, there's this green pawn right here. Yeah, so I guess here's the this red square. That's the mouse, so I can move it around with the WASD keys. And you'll see on the left side of the screen that's showing the current position of the mouse. Uh, considering that the origin is in the top left. So for example, so we're on a blank spot right now. It just says 5-4, as in the coordinates of the spot. If you press K to see the possible moves, uh, right here we can see that it's that the current position is empty, which checks out. But for example, if we actually did something more exciting and moved the mouse to a pawn and press once again the letter K as in kilo, um, we can we can the console return or prints out that the current position holds a white pawn with a point value of 1. And you can and these gray boxes represent the possible moves for the current chess piece. So yeah, you know, um, this only has one sort of move, which is interesting. I didn't expect that to happen. Let's check out this queen here. Oh right, no, that's not the story. Story, no. Let's go back to this pawn, right? Yeah, it's not showing the moves, it's like the current position, which I should have just run off the screen, right? But for example, this queen here, we have multiple different moves. Um, so yeah, that's pretty cool. Let's and for example, this knight too. So it can move in an L-shaped pattern, which happens for all knights. But let's get the show on the road here. So I've selected this green pawn, and for example, I want to move the pawn to the point 4-4, which I can because it's a gray piece right now. So I can just press the letter M, and you'll see on the left-hand side of the screen here, it says you pressed M. So it's asking for an X coordinate. So enter 4, and then press return. And then it's asking for a Y coordinate, and I'll press 4 again. I'll press return. Uh, and then you see it's spat out some output saying you're currently in the move to function, which is just from debugging. But the most important part is trying to move the white pawn from 6,4 to 4,4. Let's go back to this window here, and we'll take away the gray boxes, and you can see that the pawn has moved um, to the 0.44. That's pretty cool. Um, yeah. So just to demonstrate the capturing abilities, we'll try it out with the current selected piece, which is a black pawn. So we'll press K again for the possible moves. I can move it to 3, comma 3. So I can press M. We go back to the terminal. 3 for X, 3 for Y. And it says trying to move the black pawn to 1, comma 3 to 3, comma 3. We can go back to the window and then take away the gray boxes, and the pawn is right there. So capturing, right? Let's say I want to capture this pawn, right? I'll press K, and you see how I can now move forward to the point 3, comma 4, but I can also capture the pawn at 3, comma 3. So that's as easy as just pressing M again, and you'll see the same sort of "you pressed M" dialog has come back up in the terminal. I'll enter 3 and 3. It successfully moved the pawn, the green pawn to the blue pawn, and it has captured it. Let's take away the boxes to make sure. And there it is. So yeah, so the capturing works, moving works, basically the integral parts of all chess games. Um, so you might be thinking to yourself, "Wow, Liam, this is a really janky way of setting up the moving uh, functionality of your chess pieces." Well, yeah, I admit, yeah, it's not my best work, but let's take a look at this code for a minute. It's gonna be quick. In the main loop, I'm checking for WSD, K, and M keys. Um, for like movement and looking at possible moves and moving a piece. In this M, yeah, so this is all in a match statement, which is saying like this game state variable is going to have some sort of no, sorry, this window.get keys pressed is going to return some sort of key, right? So it could be an A, or it could be a D, or it could be like, whatever. Uh, and then, so say I press M, right? Um, yeah, so if I press M, it executes this block of code. And then so if I pressed M to move the piece, so the it would take the current mouse position, but how does the program know where you would want to move the next piece? You need to do this whole thing again and then put it back in this block of code, which doesn't which I definitely tried to see if I could get it working, but I think it has something to do with the context. Um, but yeah, I probably could um, uh, I probably could figure out a way of fixing this in the future, uh, because this function should this function is present for this entire match statement scope, right? And then so if I put the same function in this block of code, that should be existent for that should live in memory for all of this logic. Oh shoot, all of this logic. What have I done? There we go. Um, that's another cool thing about the Rust programming language. You can say cargo FMT for cargo format, and it fixes all your formatting errors that you made, so it makes it really simple to read. Anyways, um, yeah, that's about it. So it's kind of hard to like figure out what scope you're in when calling this function because um, the inner scope inside this M block might not get the correct windows, might not get the correct key presses, or detect any key presses at all as this one um, because it might spawn a new instance of a window. I haven't really figured out what's going on now. There's really no documentation on this function right here, except for a couple short GitHub issues. But yeah, you can see here this input function looks rather similar, right? So I'm calling, and we saw it working just how it works in Python from the terminal here. Um, yeah, that was just another quality of life uh, feature that I made for myself while programming this. I could input a query, and then so I print out the query, and then I flush the output. So basically, flushing the input is like removing all the characters, so you don't have like a jumbled uh, input when you're analyzing the string. Then I do some Rust stuff, and then I just take the new line character off the string so I can do easy compares with it, and I return the string. Um, this Rust stuff. Maybe I should explain it more for those who are interested. Um, it's kind of neat. So this input string, this let mut input string new is basically just saying in Python uh, uh, input equals this. Uh, and then in this block of code right here, we're calling the readline function from the uh, stdin class, which is like standard in input and output, from the input output library, uh, which is just like a standard library, right? So if you have this programming language, you'll automatically have uh, the standard library. I can import it like yeah, where is it? That's Yeah, I can import it like right here. Um, so yeah, right here. So this gives me all access to like the terminal functions, reading and writing input, or especially reading or sorry, yeah, taking input from the user, which is the most important part. Um, yeah, so this read line function gets in a buffer, which is currently an empty string. And then that takes in an empty string for uh, to fill with like the user's text. And then this expect method is called um, if the value is basically null. So for example, let's say that the terminal window like unexpectedly closed. This this readline function would return result with the some data type and then your string hopefully, or sorry, none and error message. And then so this none value, it's basically the value doesn't exist. Um, and then so this none value will be passed to this expect method, and then the compiler does stuff with it and like warns the user that something happens and that something failed. Um, but yeah, that's about it. I just thought this was a neat tool for programming languages in general because I would like to have some warning that um, a value was null in the first case, so I can do something with that when I'm writing code that builds off that stuff. Because um, yeah, it's just really annoying having like a null pointer exception, which is common in a bunch of other different languages, like Java, everyone from the C family, so C, C++, C Sharp. Um, yeah, that really sucks. But and I'm just rambling on, so I think I'll cut it here. But